Welcome all. In this video, we are discussing about the working, design and simulation of buck converter in MATLAB. Then going to the working, buck converter is a type of DC to DC converter, which converts a higher voltage DC level to a lower voltage DC level. The basic circuit diagram of a buck converter is shown in figure. That is, it has an input voltage source Vs. Also, it has a switch to control the buck converter. That is, the switch may be either MOSFET or IGBT. Also, it has a filter inductor and filter capacitor. This filter capacitor reduces the ripple in the output voltage. Also, it has a diode and the resistance R is the load. So, this is the basic circuit of a buck converter. These buck converters are used in different applications like battery charging and is used in renewable energy resources. Then going to the operation of buck converter. Buck converter has two operation modes, that is continuous mode of operation and discontinuous mode of operation. In the continuous mode of operation, the inductor current is continuous. In this, we discuss only about the continuous mode of operation. In the continuous mode, the switch can be either controlled on or off. That is, during the turn on off switch, the switch may be either MOSFET or IGBT. When the switch is turned on, at that condition, the diode becomes reverse biased. When the diode reverse biased, the current is flowing through the inductor and the capacitor. In that case, the current in the inductor increases. At that case, the inductor stores the energy. This is the operation during the turn on off switch. In the turn off condition, the diode becomes reverse biased. At that condition, the stored energy in the inductor is fed back to the diode and to the load. This is the operation during turn off condition. Then going to the design of buck converter. So we can design the buck converter based on our requirement. In this case, we have an input voltage of 72 volt. Our requirement is to produce a 24 volt. So based on that value, we can design the buck converter. So also the switching frequency is shown. So to design the buck converter, we require some constraint. In this case, the constraint is the output voltage ripple should be less than 0.5%. So this is the constraint. Also, we have a load which is 10 ohm. So based on these values, we can design the buck converter. The basic formula for the buck converter output voltage is V0 equal to D into Vin. From that value, we obtain the duty ratio. By using other formula, we can obtain the inductor and capacitor shown in figure. In this case, the switching frequency is Fs equal to 30 kHz. So our time period is 1 by Fs, which is shown here. So based on these values, we can design the buck converter in MATLAB. We are going to draw the circuit and simulate it in MATLAB. For that, first we find all the components for the circuit and draw the circuit. So the circuit is completed. Then we are going to give the values of all the blocks. In the pulse generator, we change the period and also the pulse width. So the calculated period is
After running the file, you can check the current and voltage waveform in the corresponding scopes.